In this tutorial, we'll have a look how you can keep even pixel density across your assets in Houdini procedurally. And in the second part, I'll show you a little asset that I made to help with this task. So here is a simple way how you can even pixel density of these two models. And if you're curious, I'm using models from my recent bundle. You can check it in the links in the description. So I set it up so they have uneven pixel density like this, and what you could do is just put in just delete it, a UV layout node, and now this is a coincidence that largest packable is somewhat the same. If you would have something larger, let me just duplicate it a few times. You see now it doesn't work. Just put in something small, 5. Okay, so now it doesn't work. But what you can do is change it to not largest packable but fixed, and now play with the multiplier. So something like strike 0.22. Alright, and this looks fairly decent. So this is a really simple way how you could even the pixel density. But as you can see, it's not perfect, and the problem is once you change the geometry, it no longer works. You have to go back in and readjust the ratio. Sometimes one gives errors. So you have to go in and play with the scale again. So this is not really optimal. And that's why I came up with this procedural solution. So in here we have basically the same geometry. We have our one sign and another one. And here it goes through the system and it evens out the pixel density, as you can see. And the benefit of this system is now if I change the geometry, it doesn't matter, it will still set the correct density. So no matter how much surface area I got, it still works. Or I can try this geometry. I still get great results. So for example, I can change the density and I get the same. Well, this is because the standard big head doesn't have all UV islands the same pixel density, so it just scales everything all together. It gets like an average value, so that's why you see this. This is the original geometry, so that's why this happens. So it might be a good idea to even the island size before you run this tool. Okay, so that's what we'll be doing. And as you can see, it works if you change the pixel density or if you change the scale. You still get perfectly same pixel density. Now, one thing I would like to warn you is that right now Right now, all our UVs are inside this our standard UV space. So something like this, like a big one. And now it gets scaled, so each island can be fit into the 0, 1 space. But if it's larger, the UV layout won't work and won't pack it, and you'll get errors. So I can show you that. So we'll just need to, let's say we need to scale, yeah, something like this. We need to scale our density. So now you see it's larger than the 0, 1 space, and now if I UV layout, I will get an error. It won't pack. So I'm gonna hit escape to cancel it and just bypass it. And now if I scale it down and run the pack now, it works and it packs the UVs very nicely. So that's one thing to be aware of. If one of your UV islands is larger than the 0 to 1 space, it won't pack, like the UV layout will sort of crash. It just stops working. So how does this work? Okay, so you have this is your source, like your reference pixel density, and this one is the one you wanna scale it to. And first of all, we need the surface area of our UVs, and for this I'm using a little trick that I got from the game dev UV visualize. So in here you have the option to view world space, and there's a little Vex code inside it which I borrowed. So it's something like this, and now I can measure the surface area of my UVs, and then I just promote it to a detail attribute. We'll have a look at this in detail further on, but basically I get the surface area of my UVs, then I get the surface area of my model. I get a ratio of these two values, and I do the same for the other one. So this is my second model, and as you can see, like, this one is much larger than the previous one. And from these two ratios I calculate a value, like a multiplier, which I should multiply my UV size. So if I disable it, see, super large, and if I disable it, it shrinks up. So with this we get the correct value. So I'm going to show you how to do it. Let's talk a little bit about the theory behind this. So we have our input 1, which is the first sign, and the input 2 is our second sign. So from this we're going to need the UV area, which we can call x1, and we're going to need the surface area, which we can call y1. And the same for this. UV area will be x2, the surface area will be y1. And it is important you keep this order. And from this we can get a ratio of the surface area of the UV area to the surface area, which will be x1 to y1 is z1. The same for this y2, it's x2 to y2 is z2. And this and this is different, this and this is different, so none of these four are the same, and this means that probably these two won't be the same. So now z1 equals z2 multiplied by some number. So if we get something like z1 to z2, we'll get our ratio. So now I'm going to show you how we'll get this number in Houdini. Let's set up our system in Houdini. So here we have our two models, and it's very simple. It's just a bundle model with some UV layout. So this thing just lays. I'm going to press Ctrl 4, space 1 and space 5. So if I disable it, now I can see it's packed in UDIMs, and let's just pack it in one UDIM and a quick shape to visualize our texture. The same in here. One thing, a bonus, is I scaled the UVs so we can see clearly the difference. And just put in a copy node so we can see changing in the surface area. Just move it aside, and that's it. Looks like I didn't move it aside enough. Right, so here we have it. Now, and for the UV layout settings, I think these are just default ones, so nothing special. Now we're going to start with getting our surface areas and UV area values. We're going to start with the UV area values. So first of all, let me just use a vertex split so we can split our vertices. Basically cut in our geometry where the UV borders are. For this we're going to use the attribute UV, and don't forget to promote it to point attribute. Now we're going to use the attribute wrangle node, set 2 points, and I'm just going to copy my previous expression. Don't worry, I'll paste it into the YouTube video description, so you can also just copy and paste it. And here we have it. Our geometry is transferred into UV space. And what this does is basically it blends between the world space position and the UV space position. So a simple LERP blend. Now we're going to use a measure sub to measure the surface area, and I want to set this to throughout. It was per element. I can press Alt left bracket to split the view and go to geometry spreadsheet, go to primitives, and now you can see the area is different per each primitive. So this one, I'm going to set this one, and this is the overall surface area. So it's like 0.6 meters. And now I just want to promote this. It's not too necessary, but just for sake of the cleanliness, I want to promote this attribute from area to details, so we have only one. And in case you're curious about the coverage, that's from our previous, the UV layout node. So that's why it's there. Now, but back to our thing. I want to promote the area attribute, so it's primitive, new class will be detail, and the original name is area. So now I promoted it to a detail attribute, so we get only one of these things. Alright, perfect. And now we're going to use these two nodes to get the area of, I can see we get different area value. this is the area of our model, and we're just gonna copy and paste it and get these same values from our other model. And just to be clean, we can create a null, and we'll call this out x1. Oh, turns out I have already these out in here, so I can use the same. So let's call it out1 x1, and this one will be our y value, so y1. I can just copy these values, these nodes, and we'll create out x2 and x and y1. So, and now in here we can create another null, and this will compute a ratio. And for this, we're gonna edit the parameter interface and create our own attributes. We're gonna need 6 of them, 1, 2, 3, 4, 5, 6, and 7 for the final ratio. So the first one will be x1, now the x, and let's go y1 and y1, now x2 and x2, y2 and y2, z1 and z1, now z2 and z2 parameter, and be careful not to mess up your parameter names, otherwise it won't work. And this will be a ratio. So we got all our parameters prepared. So let's just apply, accept. Now we need to get the detail attribute to this parameter. So for this, we're gonna use this code detail. Now we have to point it to the geometry where we want to get it from. So it's out x1, and we need the area attribute, and this is default value in case it can't find anything. So yeah, looks like it works. Let me just split the view again, geometry spreadsheet, and now I can see. Let me just go in this node, spin it, and now you can see this looks like it works. So I'm just going to copy this one, paste it in here, paste it in here, paste it in here. For this, we're going to use y1. For this, we want to get the x2, and for this, we want to get the y2 attribute. So now we should get our correct values. So this is correct, 3.5, this is correct. This is the x2, correct, and this is correct. Alright, and now if you remember, we want to get this z1 ratio, which is x1 to y2. So for this, now we can make it the easy way, just copy parameter and paste relative reference, and now just divide it by y1, and we should get our ratio. And now we need our second ratio, which is this. Okay, so let's recap. Now we have our x1, x2, y1, y2, z1, which is this ratio and this ratio, and now we need to get this final m ratio, so which should be z1 divided by z2. So now I can just copy paste it, should be z1 divided by z2. We get our final ratio. So now if you use UE transform, plug it in, copy this parameter, and paste relative reference in the scale in all three channels. Something should happen, but not exactly what we imagined. And this is because we're dealing with surfaces which are square areas, so we need to square root our result sqrt in brackets, and there you have it. Now it works perfectly. So now if you would use a UE transform node and scale, you have your own perfect even pixel density little tool. And of course it works for all our previous examples. Get the perfect result. And a final tip, if you want to lay out your UVs, you can use the UE layout node. And just make sure to untick scale islands. If you don't want to have it rotated, click to none. Just change to fixed. And now if you plug it in, your UVs are laid out. And if you have a lot of UVs, you might change it to UDIM tiles. So now in this case you see these islands are quite big, so I might need to go to my reference geo and just scale it down. Yeah, not as much, something like 0.3 should do the trick. And now my UVs are nicely packed and they all even. So I also made a little asset which helps with this task, and if you are my Patreon subscriber, you'll get it for free on my Patreon channel. So let me show you what you can do. But I just want to warn you, currently it works only in Houdini Indie. So this is my setup. I'm just using the base test geometry, and I'm doing some UV layouts to even up the islands and pack them on one UDIM, and just scaling them a little bit so they're more visible. And then I have a custom group for the head and a quick shade to visualize the texture, and some other custom transforms which I'll show you later. So if I would use my little asset, just plug it in, and now first thing that's very handy, you can use quick shade. And sometimes the merge doesn't refresh properly, so you have to change the display flags a little bit. So now you can control displaying the quick shade, and first thing you want to do is just put in your reference object where you want to pick your pixel density from. So in my case it's this one, but can be any node. And now you can hit picks the pixel density, so you're good to go. So if I would change it, this pixel density updates, just scale it back to 1. And now sometimes you may just want to sometimes you may just want to pick some pixel density from a specific area, like in this example from the head. So if I would want to do that, I could use the selection only, and I could use the head group, which I set up previously. And now everything will have the same density as my head on the reference object. If I would want to have the density of the pants, I could just use the pants group, and now it has the same density. And sometimes you may just want to change the pixel density on a certain part of your model. So for this, I can use this selection only. I can also show it. Now currently I'm changing the pixel density on the whole mesh. You can also change the color if you want to. So if I would just want to change it on let's say the head, I'll put the head group, and now it only changes the pixel density, just the pixel density on the head. Well, this will be resting. So that's very handy, and you can also visualize it. So, and right now you can't select directly the primitives you want to affect, but I made this little parameter in here. So if you unlock your asset and then go inside, you could just do it manually. So you don't need to use groups, but I'm using a UVI lens in this case. So as you can see, you can do it by yourself, or what I could do is just put in a group node and either make my own custom group or just select the primitives I want to affect, something like this, and then just copy these numbers and paste it in. Or also if you have some really specific polygon that you know you want to pick the density from, you can just show the number of those primitives and just paste in this number, for example. So that would be actually probably more helpful if you had something like a box. This could be your reference pixel density box. Something like this. You can merge it together. The vertex normals and maybe UV transform, and I would want to grab this pixel density for the pants. would have to plug it in as my reference object. This is my reference object, not the pants. But for example, I want to pick this number 5, this primitive. So I could do that here. Now it doesn't change anything. I would first have to go here. See, now it's picking just the density from this primitive number 5. Okay, and another useful thing. Oh, you can also invert the selection. So also for the reference object as well as for the primitives you want to affect. And let's not forget about the multiply. So if you want this group to, this could be helpful. For example, let's just have let's just pick the density of the head. So now it's the same, but let's say we would want to have it twice as dense, so we can just multiply with this. But another useful case where you might want to use this tool is like you have several different objects with different pixel density. So let's say this is our reference cube that we want to pick the density from. So you could just go in here. You could just go in here, use the V tool, quick shape, and I could just plug in your reference object, and now we should be picking the density from the cube. Let me just copy it to the other objects as well. And now if I would go in and change my reference, all of the objects are changed as well. So very handy, very procedural. Now one thing to keep in mind is that the pixel density is scaled correctly, but the UV islands are just scaled, so they're not packed. So you would have to do that. You would have to do that afterwards. So just be aware of that it doesn't pack your islands. Alright, so I hope this tutorial was useful for you. Thanks for watching and see you in the next one.